In this last video on the chemistry of hydrogen-containing compounds, I wanted to talk a little bit more about the hydrogen economy and the barriers that the hydrogen economy faces. At the start of this unit, we introduced this idea that H2 is a pretty appealing energy source. There's a lot of energy built into that HH bond, and the combustion of H2 is a very straightforward reaction. Unfortunately, the hydrogen economy faces significant challenges, primarily connected with H2 being an inconvenient molecule, an inconvenient element in a number of ways. So, first and foremost, elemental hydrogen is not generally available on Earth in convenient natural reservoirs. We can't just dig underground and expect to find H2. This means that we have to generate the H2 from hydrogen-containing compounds on planet Earth, and the vast majority of the hydrogen on planet Earth, and there is plenty of it, but the vast majority of it is in the form of water, H2O. Now, we know how to get H2 out of H2O. That's actually a redox process. All we have to do is reduce H2O to H2, and we can do that using electrolysis. We can also think about generating H2 by using hydride, H- to deprotonate H2O, producing H2 and hydroxide. But those processes both require energy, and the energy sources required to get those processes going are problematic in and of themselves. Electrolysis, the energy source, the need for an energy source is fairly obvious, right? We need a source of electrical power, but even using hydride, we have to generate that hydride in the first place. The hydride contains chemical energy, right? And so we need to use an energy source to imbue wherever we get the hydrogen and hydride from with enough energy to become the hydride anion. So energy generation is part of this equation, almost regardless. We can't just dig or look up in the sky for H2. Electrolysis is probably the cleanest method of producing hydrogen in this way, but exactly how clean it is depends on what energy source you're using, right? If you're still using fossil fuels to generate the electrical energy needed to electrolyze water, you're not really solving the problem that the hydrogen economy aims to face in terms of creating cleaner energy sources for the economy. Using coal-fired power plants, right, sort of cancels out the benefits of generating H2 as your fuel. And so this leads us into the idea of renewable sources of electricity, things like photovoltaics, solar cells, nuclear power, wind, hydroelectric, where we're avoiding undesired pollutants, avoiding the greenhouse effect due to the generation of CO2, things like this. And so this is motivation for developing these technologies so that we can generate H2 in cleaner ways. Even so, though, we still have the issue of transporting and storing hydrogen gas. There's the rather famous example of the Hindenburg blimp, which was a hydrogen-based blimp, a blimp based on H2 as the fuel, that famously exploded when the hydrogen gas on board effectively exploded, right? It was, in many ways, it was a walking bomb having a flammable gas in a blimp high up in the air. And so that highlights pretty dramatically the issues with transporting and storing hydrogen gas. A solution here could be either compression or incorporation of the H2 into a solid. So we could imagine compressing down to liquid hydrogen. This is what's done, for example, in propane tanks. If you go to your gas station and buy a propane tank for a grill, that's liquid propane in there that becomes a gas when the valve is open and the pressure is released. A solution for hydrogen is what's known as solid hydrogen. There are compounds that can either sort of incorporate the H2 molecule or actually react reversibly with the H2 molecule so that it can be stored and then released later, either through a chemical or physical process of the H2 being generated via reverse reaction or just escaping from the spaces inside the solid. And so you'll see, for example, solid metal hydrides used here. Even something as simple as palladium metal can absorb a bunch of H2, but there, as with a lot of transition metals, the cost of palladium itself becomes prohibitive. So this is an active area of research, solid hydrogen storage, developing new materials to store hydrogen efficiently and reversibly. not on the slide, but reversibility is key. It's great if you can put hydrogen in, but if you can't get the H2 back out, that's not going to be useful as a transportation mechanism for the fuel, right? Wouldn't be very useful to put gasoline on a truck without a mechanism to get the gasoline back out when it arrives at the gas station, right? That same kind of idea. So the hydrogen economy has faced significant barriers for many years. The fundamental chemistry really makes sense. It's just the issues of storage, transportation, the hazards of hydrogen gas, the fact that it is a gas and takes up a huge volume per mole, creates some significant barriers for this mode of economy.